for every action, there is an equal and opposite reaction. Let's write this down. Equal and opposite reaction. Now, Newton's third law is perhaps the most difficult law to understand, or we can also say it's perhaps the easiest law to misunderstand. Why? Well, because it means that if I push something, that something must push me back. Now let's see why that seems like it is completely unreasonable. Let's look at my usual example of a ball. Okay, and now let's say let's say that's me standing next to the ball. That's me, and then I give the ball a push. Let's say I give the ball a push with my hand. So the ball flies out. Alright, ball flies out. Maybe I throw it, or maybe I just push it along a table. Okay. So let's say I just push it along the table. Let's say that's the table. Okay, and I push it along the table. Now, if I give the ball a push, then and the ball moves, I don't move. I'm still standing. I'm still standing there. So surely the ball has not pushed back on me. Right? If I give the ball a push, the ball can't possibly give me an equal and opposite push, because the ball moves off very quickly and I don't move at all. Right, so that's why it doesn't seem reasonable. I mean, why does Newton's third law say that there must be an equal and opposite reaction? So that's the tricky part to understand. Now, we'll look at a few examples to sort this out. Starting with this example, the reason okay, that when I push the ball, okay, I don't seem to move, whereas the ball flies off. The reason is because in this case I'm much more massive. Alright, I have a lot more mass than the ball. Okay, I have more mass and the ball has less mass. In everyday words, we say that the ball is lighter. Okay, but since we're doing physics, I'll use the term mass. So because the ball has less mass, okay, when I push it, let's say when I push it with a certain force, it might fly off quite quickly. But if the ball pushes back at me, with that same force, I won't fly off. I won't fly backwards, because I have a lot more mass. So, but I would, to be very precise, have a very slight backward motion. Like a recoil. You know, people talk about a recoil when they shoot a gun, and when the bullet flies off, the gun moves backward. We call that a recoil. So when I push at the ball, I will move back ever so slightly, but just very slightly, that maybe I don't even feel it, because I'm so much more massive than the ball. So in a way, this explains why it does not feel as if the ball has pushed back on me. Now, So if it's so not obvious, how do we know it's true? How do we know that when we push something, the something will always push back at me? Now there is another example we can think about. Now, let's say let's say if I continue to look at this example, but instead of pushing at the ball, let's say the ball is not there, or well, maybe it's there, but let's say instead of pushing at the ball, I decide to push at the table. Now the table is a lot heavier than the ball. Let's say I have a very heavy table, so I decide to push at the table instead. Now, if the table is very heavy, when I push at the table won't move. But if I push really hard at the table, all right, if I give a sudden, very hard push at the table, I might even fall backwards. All right, and that's because the table is, when I push at the table actually pushes back at me. All right, if I hold onto the table and and push my hand out very hard, right, I can actually fall backward. And it's the same if I push at the wall. All right, if instead of the table, okay, if let's say I have a wall down here, and I push at this wall. Okay, I push at the wall very hard. Right, if I push up my hand very hard at the wall, then I would actually fall backwards if I don't stand properly, and that's because the wall pushes back at me. Now, as another example, let's say let's say I'm standing on the ground here, right, on the field, and let's say I squat down. Okay, I squat down, and I push downwards with my leg. Okay, I push very hard with my leg. I push downwards. What happens? Oh, when you squat down and push very hard with your leg, that's what you do when you jump, isn't it? That's what you do when you jump. So when you push downward very hard with your leg, you fly upwards, well, maybe for a few centimeters, and then you fall back down again. So when you push downward very hard with your leg, the earth below you, it actually pushes back up at you. It actually pushes back up at you with an equal and opposite force, and that's what causes you to jump up. Okay, so that's what jumping is about. It's really about Newton's third law. All right, it's because of your action on the earth by pushing out a leg that the earth gives you the equal and opposite reaction that makes you fly up. When if we push at a hard wall, or if we jump, how the effect of us falling back or jumping up shows that there must be a force pushing back at us, either from the ground or from the wall or from a heavy table, even though it's not obvious if you push a ball. But there's another reason why it might be hard to believe. Now the reason is that when we push something, let's say when we push a ball or when we push a wall, all right, we are sure that we are applying a force to the wall or the table because our hand moves forward, all right, or our hand pulls something backward. So we always think that when we push something, our hand must be moving forward. okay, to make that force. And the reason why we might think that if we push at the wall, or if we push at a jumper from the ground, all right, we might think that the ground or the wall would not actually have cannot possibly have a force pushing back at us. You might think that because the wall and the ground do not move, right? It is important at this point to clarify this. The fact that the ground or the wall does not move does not mean that they don't have a force. So just by the fact that simple fact that when you stand on the ground, that you can stand on the ground, already means that the ground must be exerting a force up on you, because otherwise you'll fall right through the ground, right? you have a weight. There's a weight pulling you down. So if the ground does not have a force acting up on you, you would just fall down, fall through the ground. Okay, so this simple fact already tells us that there must be a force on the ground. It's just that from the ground on you when you're standing on it, and it's just that if you like squat down and push yourself up, what you do when you jump, when you do that, you're applying an even bigger force downward. All right, you're pushing down with an additional force to your weight. So the ground would also exert that additional force that pushes you up, and that's why you fly up when you jump. But the ground can do that without actually moving. It's simply because the force from the ground appears only when you push at it. All right, so as you push at it, you are pressing your legs against the ground. Okay, and in pressing the legs against the ground would react with a stronger force. All right, so that the ground stay at the same level. The ground doesn't get pushed downward by you. Okay, and a ground can actually get pushed downward by you if instead of a solid ground, you have a thin wooden platform, or if you're standing on a table. All right, when you try to jump, the wood or the table might crack. So, and the wall doesn't actually move. There's a name for this kind of force. It's called a reaction. A reaction. So when you push your leg downwards like this, when you push your leg downwards, okay, and the ground exerts an equal and opposite force, all right, so that the ground would not move at all. This kind of force that happens from the ground only when you're pushing at it is called a reaction. And it's the same. It's the same when you push at the wall. When you push at the wall, and the wall pushes back at you, okay, so that the wall doesn't move, that's called a reaction. Now, in the case of a ball, of course, when you push at the ball flies off. But when your hand is in contact with the ball, when your hand is pushing at the ball, right, during that short time, the ball would also be pushing back at you. In this case, the ball moves. Okay, in this case, the ball moves. So it's not just when the thing doesn't move that you call it a reaction. Okay, we call it a reaction anyway. If it is a force that pushes back at you when you push at it.